In this video, we'll present user sequence modeling for sponsored product click and conversion prediction, the ranking model at Wayfair. So in the final ranking of the sponsored product, we need a scoring model to predict the customer engagement, such as click-through rate and conversion rate. Right now, the two probabilities are predicted by a multitask deep learning neural network that integrates customer, product, and request context. The model then modeled those interactions among those features by the crossing layer. And as like a lot of traditional conventional model, this rely primarily on aggregate statistics and static features. So the goal here is to include a sequence-aware personalization module that can react to most recent user actions in real time to unlock deeper personalization. So we do this by integrating a sequence-aware module into our multitask ranking model. So the overall architecture is shown on the right, where we have early Fusion-based tokenization sequence. Those goes into a lightweight transformer to be processed. And then the output embeddings from this transformer are concatenated with the existing static features. Together, they go to the crossing layers, and we have two prediction heads for each engagement metric. The token here includes action type, for example, click, add to cart, favorite, historical SKU ID, the SKU that customer interacted with, candidate SKU, the SKU we're scoring. So this is called early Fusion. And we also have the positional encoding in the token. Once we have the overall design of our architecture, we have done extensive ablation study to study what's the best design of each factor, what is driving the most model improvement. The first driving factor we have found is that sequence context is very important, especially making the sequence longer. We started with 100 most recent action, continue to 300, which has at 300 compared to 100, it has delivered consistent offline improvements in terms of AUC. Also worth noting is minimum sequence list being 1 helps capture immediate customer interest within section. SKU representation or embedding is also a key driver of the offline ranking metrics. We replaced a baseline embedding system by concatenating two different properties of the SKU. One is a visual embedding system, one from the semantic embedding system. We have found that together, they create highly robust and multimodal item embedding and improved offline metric. Further, we have found a particular useful sequence summarization, which is called candidate aware. In particular, HI is the raw transformer output. This particular candidate aware pooling of all the raw hit transformer output is a weighted average, where the weight is defined by the similarity between candidate SKU and the historical events. So the final summarization of the user history is more related to this candidate we're scoring. We also found including action bias is another driver of a better summarization because multi-action history contains asymmetric densities. Different action indicate different customer intent, like purchase, add to cart, favorite are higher, more clear intent, while click is a more exploration. So the action bias assigns different weight or bias adjustment to each of the action. One particular failure mode we have learned is heavier behavior-aware attention may not work. We have tried to have each action has their own QKV transformation, but this added model complexity significantly without a consistent ranking quality gain. Finally, we have a 5-week live test of this final WaySeq design, which has yielded significantly business results gain across key funnels, especially with a significant CTR lift, order per impression, and ROAS, which indicate the model is benefit to both Wayfair, supplier, and also our customer. Cool. So to summarize, the practical takeaway is broader behavior coverage and stronger skill embedding provide consistent system gains. Candidate-aware mechanism is proved to be a pretty effective way of summarizing the sequence. And this should be taken care before introducing more complicated attention mechanism. Future work could include extending this work to ultra-long behavior sequence, as there are a lot of existing work already, like retrieval or lighter attention design. Multimodal signals that further enrich the item embedding, item in skill understanding could also be helpful. Finally, we can explore generative pre-training for the sequence module that also takes advantage of the pre-train and next item prediction. Thank you so much.